you give the same rate, so if a sample is here, plus minus 2 standard errors will contain the population mean in that range. But if a sample, I pick a sample from here in this range or here, plus minus, so this one is somewhere, the mean is somewhere here. Plus minus 2 standard errors, it ends at here. The population mean is not covered in that range. Which is what we saw in the previous simulation. Same thing I'm showing in a different chart. Okay. So any sample that you pick in this range, that will have the population mean covered between the plus minus 2 standard errors. Any sample that is outside of this will not contain. That's pretty much the difference also between how you look at confidence intervals and hypothesis testing. Hypothesis testing, I will cover that in detail later, but we see there we check, is the sample in this range or in this range? If it is there, then we make a decision. Here I am checking, is the sample within this range? Same thing I am doing. If it is, yeah, it will be in this range is what I am saying. In the other case, if the sample is there, it will not be in this range is what I am saying. Same thing, nothing else. I don't know why it has to be complicated that much. But that's what it is. So at this point, confidence interval clear. What confidence interval is saying? If I have taken a sample, I will not be taking multiple samples again. But if using the same methodology, if I were to repeat the samples again and again, if I were to collect more and more data, 95% of such samples will contain the population mean in the range I am specifying using the sample. I am 95% confident. 5% I make mistakes. See, and you see slight differences between how the Americans present the data versus how we present it in our newspapers. And here, this was still in last November or something. Last February actually. They give some more details about the methodology, what they have used. 1,473 adults were polled and margin of error is 2.9 percentage points. So Trump has 40% with a plus minus 2.9% margin of error. There's a new word now introduced, margin of error. It is related to standard error. It's not exactly standard error. It's some multiple of standard error. I will talk about it. And that's related to again the what confidence amount of data plus minus 2, same thing. So let me not rush. I'll talk about it. What it really says, margin of error is the maximum range within which you will see the true population value. Okay. So if you were to repeatedly do that, this is the maximum variation that you would expect with that confidence. Okay. So anyway, so we see this all the time. We just didn't realize that we have been seeing confidence intervals all the time. 6-day delay in monsoon. The monsoon is likely to set over Kerala on June 7th with a model error of plus or minus 4 days. Whenever you see those plus or minus, they are talking confidence intervals. Okay? Whenever you see the word margin of error, you are talking confidence intervals. Okay? So the IMD have a range of plus or minus 4 days and the prediction is done daily. Weather forecasting is a very complicated thing. So on June 1st, they say monsoon is likely to set on June 7th with a plus or minus margin of error of 4 days. On June 2nd, they will again say no, it is not June 7th, it is June 6th plus or minus 4 days. So, on June 9th, plus or minus 4 days. On June 3rd, they will say plus or June 10th, plus or minus 4 days. Somewhere it will come. Okay? No, but it's complicated science. But that's what really is being done, plus or minus 4 days. But plus or minus 4 days also we need to understand what confidence level they are not mentioning. Is it 90% confidence, 95% confidence, 99% confidence, 68% confidence, 50% confidence? What is your confidence? They are not mentioning that. The rule of thumb, most of the time people don't mention. When they don't mention, 95% is default. When someone doesn't mention their confidence level, 95% is the default confidence level. Plus or minus 2 standard errors.
How do they arrive at like plus or minus 4 days in this case versus your previous slide where you said plus margin of error is like plus or minus 2.9 or something of that sort. Is there some random number that they choose, or is there some sort of a definition or some way to derive that number?
Anybody wants to answer this? It's a standard error. See, plus I want 95% of the data covered. I want the x-axis values for those. That's what those plus minus 2.9 are.
Okay.
How many standard errors? I want 2 standard errors covered. Okay. That plus minus 2 days is that plus minus 2 standard errors. Plus minus 4 days. It's calculated as that. The Z-score calculation or the actual x-axis Q naught. Q naught will give you that number. So that's why I'm saying I'm going to be repeating the same text. There is nothing new actually I can teach. I will introduce new words and new terminologies. Many of the times it's just the previous one, whatever we have covered, being stated in a different way. There is not much I will add actually from this point onwards. And yet I will introduce hundreds of new terminologies. But try to see them in relation to what we have already covered. Same thing. Okay. So that's what I'm going to be doing here. We hear standard error, margin of error, confidence interval, sample size. What is all this relationship? What am I talking about? We have already seen central limit theorem has told us standard error is population standard deviation divided by square root of sample size. That we have seen. Keep remembering this. Whenever you hear the standard error or the mean, just remember that demo, the wow demo. That's it. And things will come to you automatically. Oh, standard error. Okay, that's what I know. Big deal. Okay. Margin of error is nothing but some multiple of the standard error. That multiple is decided by how confident you want to be. That Z-score, do you want within that 68% of the data covered, 95% of the data covered, 99.7% of the data covered, or any number in between them, 90%, 85%, what is it that you want covered? How confident do you want to be? That will give you the Z-score. Multiply that Z-score with the standard error, that's your margin of error. Okay. Normally when people don't give you that number, I said 95% is the confidence level they will form. So this is again, that's all I need. I know of Dura. Of course I know that also. Yeah. So now, what is that? Standard error. Let's assume this is the sample distribution. That is the standard error. Okay. And margin of error, when I say that is the margin of error at 95% confidence level. Margin of error has to be mentioned in combination with the confidence level. Otherwise, it doesn't make sense. And like I said, if it is not mentioned, default 95%. Otherwise, it should be mentioned. Okay. So, at 95% confidence level, that is the margin of error. Minus plus. The moment you say plus minus, that is your confidence interval. Margin of error is half of confidence interval. Or plus minus margin of error gives you the entire confidence interval. What is the plus minus? Mean plus minus 2 standard errors is your confidence interval. What level of confidence? 95% of the data. So at 95% confidence level, this is the range within which the population mean will be there. Have I taught anything new here? 95% of the data being covered, I have been talking about that only forever. And how much the empirical rule tells you, plus minus 2 standard errors or plus minus 2 standard deviations is what I have said. Sample distribution plus minus 2 standard errors. That's it. I am giving those 2 x-axis values. That is confidence interval, and this is the confidence level, the area under the. What will be the margin of error at 68% confidence level? It will be the same as the standard error, because that will be 1. What will be the margin of error at 99.7% confidence level? 99.7%, Z-score is 3. That's it. margin of error is 3 times error. If 80% like Julie, then I will have to look for the Q norm corresponding to 80%. It's just that 80% has to be symmetrically divided. So 10% there and 10% here. So Z-score has to be for 90% and 10%. The 80% is in the center. That's where you have to look for. So previously Julie wanted only one-sided, all taller people. Confidence interval is normally a symmetrical thing. So let's say Julie also said, I don't want very, very tall people or very, very short people. I want 80% of the middle people. Then there's the confidence interval that we are talking about is, and okay, let me just go here. And too much of a peak. Kurtosis is like, that's okay. Okay, so now here, if I want 80% of the data covered, so let me first draw what else I know how to draw. Okay, 80% of the data covered, I need this to this. Previously, Julie wanted 80% taller than that. Now she says, I want middle 80%, I don't want very tall people also. So, the top 10% of the people, remove them. This is 10%. And the bottom 10% also remove them. This is 10%. I want only the middle 80. This is the confidence level. And so, when you find the Z-score corresponding to this is P norm of, Q norm of 0.9. Since it is Z-score 0, 1, and this is Q norm of 0.1, 0, 1. So that's what it is. This is the 80% confidence level, and this is my 80% confidence interval. That's it. I'm just identifying the corresponding Z-scores and Z-values and giving the range. Margin of error is whatever the Q norm you get for this. Let's say so I do a Q norm of what is it? 0.90. That is 1.28. So 1.28 times the standard error is your margin of error. No, she was already gone out, so she was outside the entire curve. No? We calculated the Z-score for that. What was the Z-score for Mrs. Adler? Z-score for, not the Z-score, it's a Z-score. What is it? 349 minus, the average was 266, divided by, standard deviation was about 9 variance, or standard deviation was 9 point something.
9.2.
Wow, see that's, 9 standard deviations are there. Even, so getting near a 6 sigma process or something. Actually beyond that also. 6 sigma, 3.4 defects per million is acceptable. So, now Mrs. Adam, you do whatever you want to prove her, right? Okay, so margin of error is just some multiple which is based on the confidence level you want. Confidence level is the amount of data you want covered. That's it. So Same thing, there is absolutely nothing new from whatever we have covered 10 years ago. And so the margin of error and the relationship between sample size.
What is that?
As sample size increases, what happens to margin of error? Decreases. So the standard error decreases. It's in the denominator now. Sigma divided by square root of n. And it makes intuitive sense also. If I take a large sample, I will be inferring about the population better. No? It is better representative of population. So the margin of error will always be lower. Smaller sample will give a larger margin of error. Makes sense even without formula. And that range is the confidence interval. Different. Okay, and so we see this all the time in the newspapers. The Brexit problem. UK opinion polls give climate lead to Remain at 51%. Okay, the exit is trailing with 49%, 51% leading. Okay, so they mentioned that. Then UK awaits with bated breath, and somewhere something is happening. The Remain took a lead with 48% against Leave on 42%. Okay, some other poll, two other polls also say by 1 or 2 points. Well within the margin of error. Well within the margin of error. They just mentioned that in 5 minutes somewhere. It's well, but the headline of the screen, okay, they are leading. And then Euro paying 50 to 48. That's what happened. Well, why are you surprised? I think from many days before that, the indications were there. It would just go either way. But headlines always, every day there will be a headline screaming at that. And no better example than what I put the next few slides together just before coming to class today. The last 5 days of the newspaper articles. November 1st, watch it. Trump just 1 point behind Clinton. November 2nd, Trump in lead by 1 point. November 3rd, Trump Hillary now in neck and neck race. Both are locked at 46%. Okay? November 4th, Hillary's poll lead down to 3 points, 45 and 42. November 1st, Trump was behind by 1 point. November 2nd, Trump was ahead by 1 point. November 3rd, they were equal. November 4th, Hillary is just 3 points. Her lead has come down to 3 points. Actually, she was ahead. November, and so this goes on. Poll war, Hillary leads Trump, who leads Hillary, who leads Trump. And this article was actually some months back. I saved it when I was teaching a class in Bangalore, and this is from Deccan Herald in Bangalore. All happened. And what is happening in all these elections? All of this is in fine print here. Actually, this article is nice. This is a very nice article because they mentioned what are the problems with such polls. Depending on the mode, the method, the questions, sample size, etc., polls conducted at the same time can show a wide range of results, allowing every side to claim imminent victory. All the elections are still more than 4 months away, so this was 4 months back actually, more than that. But last 4 days also the same thing is happening. Okay? Nice articles being written. So this week's crop of polls shows Hillary Clinton leading Donald Trump by double digits in an ABC poll, 51 to 39. Only 5 points in an NBC poll, 46 to 41. And a virtual deadlock in Winnipeg University, 42 to 40. Rasmussen report shows Trump leading with a 4 point, 43 to 39. Okay? And many of the things that are missing here, what they do not show or show in fine print or notes is large margins of error, plus minus 4% in ABC poll. So plus minus 4%. If it goes to the extremes, this is going to become 47, this is going to become 43. 47, 43. But that too, that 95% confidence level, it's not 100% anymore. Then, small samples often, I don't think this is a problem. I don't think these people know what they're talking about in this article. Sample of 1000 is not a bad one. It's complicated, but not a bad one. Sketchy methods. Rasmussen is online and by telephone. I don't know. Obviously, that's a problem. Just a talk about margin of error, sample size, that same question, exact same question. Sketchy methods, Rasmussen is online and by telephone. I don't think that's a problem. I mean, these days everyone has access to online things and to telephones. Now, there was a major problem in the 1930s when the presidential election in the US was done, and there was convenience sampling. Sampling methodology changed. Random sampling was not done. Convenience sampling. What they did was they took the telephone book and identified some people, randomly picked people from there. But a random sampling from a telephone book is still finding people who have a telephone. And back in those days, only rich people had telephone. And their analysis was completely gone because they never accounted for any poor people plus people. Only rich people were there in the thing. So they might think that they have taken a random sample, but they took a random sample from a telephone book. How random can that be? So you have to think about that sample at that point. And then there is the business of the missing numbers. See, this what is 51 and 39 adds up to 90%. There are 10% fence sitters who have not decided. So, plus minus the margin of error with the number of people who have not yet expressed their opinion, that 51-39 is also may not be really a difference. And it's a complex science anyway. Okay? So this is what is happening. So what do you do when all of this happens? That is yesterday's newspaper. November 5th. Monkey King says Trump will win. And there is a monkey in China that seems to be just like the octopus that was given the World Cup football predictions. So a Chinese monkey described as the king of prophets has picked Donald Trump for the US presidency. Geda has successfully predicted the winner of football's European Championship final earlier this year. 50% chance someone will get that. Okay, so this is today. So Trump leading, trailing by 1 point, leading by 1 point, neck and neck, Hillary leading by 3 points. All that is well in the margin of error. So nothing is really changing. 5 days of newspaper articles have been given out 5 months now, but nothing really, we don't know what will happen. So that's what is happening. So it's all within the confidence interval. Margin of error is that way. Anything can happen now. Okay? So it's as good as anybody's case. So that's what is confidence interval, and we will continue with that. But just to add, just like mean, proportion, variance, variety of things are there. You can look at multiple things. Proportion is another very common metric that is used in statistics. And whatever we just saw with all these election things in US, proportions. 59% of people are voting for this candidate, 41% for this candidate, or 50, 30, 20 for other. These are all proportions. What percentage of people? The moment you talk about that, proportions. But proportion is a special case of a mean only. You are dividing by the total number. How many people voting for this person divided by the total number? So everything being divided. So proportion is also a special case of a mean only. So sampling distribution of proportions also will be the same. It will follow the central limit theorem. The same way. So in that case, expectation of a sample proportion is P. Thankfully, proportion is the same as probability. Frequentist approach. How did we calculate the probability? Frequency divided by total. Proportion is also the same. Frequency divided by proportion. Thankfully, this time they have not changed the symbol also. The same P is there. So whether you want to call it proportion or probability, same thing. Okay? Same thing. No change. So expectation of a sample proportion is P, and proportions normally follow that binomial thing. Standard error of a sample proportion is given by PQ over N. Okay. If you want, we can derive it. There is simple derivation, but same from the variance and expectation properties. It will come, but no need to unless you are very interested. You can spend 2 minutes and do that. But at this point, the standard error when we were doing means was standard deviation of the population divided by square root of sample size. Here, square root of PQ divided by square root of sample size. Yes.
What does that mean? Expectation of sample proportion.
What is in the proportions? What would you expect? What is the average? When you are dealing with proportions and not means. What is the average of the proportions?
For example, if you take
So if you take, I think I have an example where I talk about the gems. So if 25% of the gems in a packet are red color, 50% are green, and 25% green, what is the expectation? That's the P. So probability of success. In that case, I have 3 different ones, so it expands, but if I have 2, what is the expectation? Okay. So P is sample proportion. Expected value of So let's say here, let's solve this problem right now. It's right here in this problem. Okay. So in a poll by CNN ORC conducted late last year, a survey of 930 people predicted that 49% would vote for Hillary Clinton. So what is the expectation for voting for Hillary? 0.4. That's sample proportion. That's the expectation. So P is 0.4. That's what whatever the sample is giving, that's what the proportion P is for the population. So here is what has been given. Multiple polls are there. CNN, they also given MOE, margin of error, the sample size, margin of error, multiple things are there, Clinton, Trump, whatever. So now, if this is what the problem is, what is the margin of error at 95% confidence level? 95% confidence level, we have so far been saying 2. If you calculate the exact z-score against 95, you check Q norm for 0.975 and 0.025. 95%, the middle 95%, no? So this is 97.5 minus 2.5. This is 95. 95. So that's why we have checked for 0.975 and you do that. So how do I get that margin of error? Z times the standard error. Standard error is 0.49 PQ over N. PQ over N. P is 0.49, Q is 0.51. Divided by 930 is the sample size. And 95% confidence, so Z score is 1.96, 3.2%. That's what they've given here. CNN ORC 3%. In the election analysis, they normally account for some other factor that they have. Margin of error calculation exactly the same. If you go to their website somewhere, the Real Politics, their website, look at the details of how the calculations are done. The margin of error is exactly with this. They correct for this with the subcorrection factor in the US case. That has nothing to do with our statistics that we learned.
0.51, can you explain what it is?
PQ.
Q
PQ. Q is 1 minus P.
I'm sorry?
Q is 1 minus P.
Okay.
That's it. Yes.
So it is for Hillary they do it differently. Yes for Hillary and no for Hillary. And then they do it for Trump again. It's yes for Trump and no for
You
Trump.
can do that.
But how do they calculate?
Yeah, that's it. So that's exactly. Let's not complicate the problem. Whatever the information is given, you do that for everyone. Okay, good. Same thing that we did earlier. What we did here, 0.9 and 0.1, that's the same thing. So now I want So I want 95% confidence interval. Confidence intervals generally are symmetric. Although asymmetric confidence interval can be done, but not commonly used and not as intuitive. Nothing stopping you from doing it, but they are not done. That's where hypothesis testing is preferred. But 95% confidence interval I want to get. That means the middle 95% of the data. So this is my 95. Okay, this is 95%. If I want to get that 95%, how do I get that? The area to the left of this is how much? 97.5. This is 97.5%. And the area here is 2.5%. So if I have to get this Z-score, this Q norm, what is the area to the left of this? 0.975. And the area to the left of this? 0.025, 0.1. And then I subtract them to get the area. Okay. And let me show that with R also right here. Okay. So Q naught 0.975 and I get 1.96. So I get it. That's the two standard error. If you do only one sided of 95%, then it won't be 2. You will get a different Z-score. Suppose I want so you have to be very careful about what you are trying to find out. If I want the 95% data to the left of entire this thing, so somewhere here, the entire, this is the 95%. Then this is my 5% here. This is not symmetric. Now if I want to get a Q norm, what do I do? Q norm, then I do 0.95. Still covering 95% of the data. The previous one was also covering 95% of the data. But where is it? Which part? Which 95%? So here I will get. So this will be my Q naught for this one. Okay. So you have to be, when I am doing a symmetric, then 97.5 minus 2.5 is 95. When I am doing only left side at 95%, then I get 95. And that one is, what is the Z-score corresponding to that? That is, I think 1.64 or something. 1.61. Which will be the case for a 90% confidence interval. Because 5% here and 5% also if I take out 90% in between. For 90% confidence interval, the Z-score will be 1.6. Okay, now you get that. Excellent. If you get that, you will have got it. So here, coming back to the question on the previously asked question on margin of error depends on sample size. So now here I have a margin of error of 3.2%. Suppose I want a margin of error of 1% only. I don't want that much. I want to be much better in my predictions. You might say that. So you say, I want 1%. people voting, 49% are saying I vote for Quintus. Okay, that has not changed. Sample size is the only thing that can change. That has remained constant. 95% confidence, you still want the same confidence level. And if you did that, so my margin of error 1% is what you want. This is in the denominator and square root. So squares will happen. And what will happen is 9,600. You had taken a sample size of 930 to get 3.2%. To be able to bring it down by a factor of 3.2, you are multiplying by a factor of almost 10 or more than 10. That's where the problem is. It's very expensive. To now collect data from 9,600 people, yes, I will have a less margin of error, I can be better predicting, but I have to draw a balance between the cost, the time is cost, and how much margin of error can I live with. So sample size will have to be decided based on that. How much margin of error can you live with? They have taken 930, 3% is good enough for them. Okay. It's 5%, 5% might be too much, then you are not there. 3%, 2%. So you have to draw balance between those. Okay. There are other ways of looking at it. Now that I have talked about sample size with respect to margin of error, let me take a slight detour and talk a little bit more about the sample size. Earlier I was saying 30 is a statistically large sample size. One variable is there. You take 30 as the large sample size. Then there are other methods. They talk about number of variables you take, and I think 50 times or something people talk about. So these are all rules of thumb over the top of head. So 50 times the number of variables or 30 times the number of variables. You take that as the sample size. One variable, 30 is a good enough sample size. Some of the other things that we do at INSOFI, based on our crazy way of thinking. If you have categorical variables, count the number of levels. And if there is a numeric variable, just say one numeric variable is equal to 10 categorical levels. Don't ask me why. If you don't like it, make it 15. If you ask me a question, I will ask you to pick a number and say, okay, put it in, go ahead. Okay. So this is what we do. That's fine. Some random things. Then multiply with the number of classes. Classes means the dependent variable. Will not buy, will buy. Will have a high risk of heart attack, low risk of heart attack. 2 classes. High value customer, medium value customer, low value customer. 3 classes. I just multiplied that number with number of classes and then multiply it with a random number between 75 and 150. You want to multiply with 200? Be my guest. 75, fine. 100? Okay, fine. 100 is easier actually for calculation. Just put 2 zeros. Yeah, let's go with that. That's what we do. That's the reality. So, example, will a patient adhere to medication or not? Non-adherence problem. And the variables that I say, let's say we have these variables: age, income, gender, and education. All categorical with 3 levels here, 3 levels here, 2 levels here, 3 levels here. Okay? You can say on an average 3 levels are there, and 4 categorical variables, 4 to 12 levels are there. 12 multiplied by will a patient adhere or not? 2 classes. 12 to 24. 24 multiplied by the random number 100. 2,400. Let's say 2,400. No, I have only 1,800. Okay, give me 1,800. We will work with that. I have only 10. Sorry, I can't do it. Okay. That's another way of thinking about this thing. So margin of error was one thing. If you are calculating margin of error, statistics is coming into play. Use margin of error concept or use this thing. So this is what I am doing here. If broken it again into attributes and levels. Attributes are these: age, income, gender, education, and these are levels. Multiplying that with that, or simply counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If I do 3 times 4, I get 12, otherwise 11. Okay? And then classes, I just said, will they adhere or not? High value, medium value, low value customers. Rule of thumb 75, 100. That's the data set. That's another way to think about it. Multiple ways. like I said, number of variables times 30. Essentially, what you really want to have, at least from the statistical perspective, is when they say statistically 30 is a large enough sample size, that when I have 30 data points for all the variables of interest, all the 30 people should have all the data. There should not be missing data in that. Again, I say I have 30 sample sizes there, but I have age for about 10 people. For the same 10 people, I don't have income, but for another 20 people, I have income. That won't work. Okay, so have a comprehensive, then even 30 might be fine. So, variety of ways. Generally, sample size is not, for most of the problems that you deal with, is not a problem in these days. The problem is with more size of sample, the large amount of data. That's a bigger problem. You won't be restricted. If you can processing power might be the thing restricted. I have 10 million records. Now, if I run all of that, it will be a problem. How do I just get 100,000 records from that? Randomly, just like select. That's what we will have to work with mostly. Not as much restricted by small amount of data. There could be some situations, but in general, not. Okay, so confidence intervals actually done. Let's solve the problems and then we'll move on to hypothesis testing. Okay, and a survey was taken of US companies that do business with companies in India, and survey question, one of the questions was approximately how many years has your company been trading with the companies in India? They took 44 companies and the average of that sample of 44 was 10.45 years. Now, let's say population standard deviation is given 7.7 years. Construct a 90% confidence interval for the mean number of years. Let's say 10,000 companies, American companies have been trading with Indian companies. What is the mean number of years for those 10,000 companies? How long have they been trading with Indian companies? That I want for the population. I have a sample of 44 companies. 44 reasonable size. 30 is good enough for me. Okay. Tell me, how do I do it? How do I do that is what I said. What do I do is Z-score, I guess. Okay. But anyway, confidence, what is the confidence interval? So that is 90% confidence level. The interval, when I say sample mean plus minus margin of error. That margin of error corresponding to the Z-score corresponding to 90%. We just did actually 1.64. Yeah, 1.64 is what we got. So sample size 44, sample mean. So this is not mu.